All right, well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time you have a question for either of our speakers, please don't wait. Don't hesitate. Just use the question and answer tab there on your interface, and we'll try to get to as many questions as we can throughout the webinar. Also, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. And I also want to point out a very interactive chat interface that we have. So we do encourage you to use it. Say hello, let us know where you're from, and please provide your questions, comments, suggestions, whatever you got, we'll take it. All right, with that, let's go ahead and kick off today's webinar, which is Journey to the Cloud, Cloud Migration and Modernization Success and Survival. Our speakers today are Andrew Showstead, who is the Senior Director of Solutions Engineering at GigaSpaces, and Sim Zacks, who was the Distinguished Engineer at Red Hat. But before they get started, I'm actually going to turn things over to Noam Herzenstein, who is the Director of Product Marketing over GigaSpaces. And Noam, I think I stole some of your thunder. I apologize for that, but please go ahead and take it away. I'll see you guys on the backside. And if you need anything, please feel free to chat me in the presenter chat.
Thank you, Charlene, and thanks everyone for joining us today. So I'm just going to have a quick introduction of our 2 awesome speakers today. So starting with Andrew Showstead, who is our Senior Director of Pre-Sales and Technical Consultancy, as Charlene mentioned. In his role, Andrew oversees implementations of GigaSpaces Smart DIH, our digital integration hub, across cloud and hybrid cloud architectures. Andrew's background includes over 25 years of experience in international roles across several disciplines, including machine learning, AI, application development, network administration, data security solutions, as well as anti-fraud and access control management across several industries. And Sim Zacks. Sim is a distinguished engineer with Red Hat, where he's been working for the past 6 years. Sim's responsibilities include being a DevOps CI architect and leading cross-product initiatives. Sim has more than 20 years of experience of leadership across the technology stack, including design and development of software and databases, DevOps, CI, and system and network administration. So just quickly before we start, a quick look at today's agenda or the topics that we have for the discussion. We'll start by, or Andrew will take us through the digital integration hub and explaining this concept and this architecture, taking maybe a closer look at the GigaSpaces Smart DIH solution, and then we'll take one sample use case just to demonstrate. Then we'll move on to the kind of main event, the exciting part of the session where we're going to have a live demo, the journey to the cloud, and we'll see Smart DIH on top of Openshift in this live demo. Then Sim will take us through some of the Openshift aspects, and at the end, if we still have some questions left, we'll take it then. So without further ado, Andrew, take it away.
Thank you, Noam. It really is my pleasure to be here today to speak to you and to co-present with Sim today. We have a very ambitious agenda today, so let's get right to it. First off, I want to talk a little bit about our DH. What is a DIH and why GigaSpaces? So if we look at a conventional architecture of application development, at the bottom here, you can see that system of record applications and data reside on the back end, and they're tightly coupled with front-end applications. So this can be a combination of legacy platforms, perhaps DB2 on mainframe or Oracle database, other modern data stores such as NoSQL, or maybe even subscription-based cloud data stores. At the top, we see the digital applications consuming that data. And this could be across different channels, for example, mobile, web, chatbots, etc. And the key characteristics of this conventional architecture is that it's a request-based integration layer with those systems of record. It means that every time data is requested when the application needs it. So these digital applications, as I mentioned, are tightly coupled with those backend systems. The user experience, on the digital layer is dependent on all those relevant backend systems of record being available. And if they're experiencing any types of performance issues or being offline or overload, it can actually impact the digital application experience and indeed the customer experience. So from the standpoint of the application developer, each application they develop, they need to actually develop those data services to access that data. And they also need to synchronize the data between their application, the system of record, and perhaps if there's a caching layer, to also synchronize that cache. And for each application, this repeats itself over and over and over. Okay, this essentially means that this tight coupling creates a difficult arena to modernize legacy systems of record. Because multiple applications are dependent on them. And if you change that backend for one application, you're going to likely inadvertently affect another application. So summarizing this, really, it creates slow innovation. Developers need to spend time exposing the data as data services and then take care of the synchronization while they're actually developing their application. So certainly custom code is involved. This can create low performance. The impacts the user experience, bottlenecks in systems of record. They're really not designed in this case, in many cases, to service real-time requests from APIs. You can have scalability issues where you're actually not ready to elastically scale and handle extra loads. And we'll see an example of a unexpected extra load in a moment. And then finally, there's cost related to these. Perhaps it's MIPS on the mainframe that every time an API accesses data, even though it may be the same data, there's a cost incurred. Maybe it's data egress from subscription services, right? Really, this is the problem with coupling digital applications to the backend system of record. Some other key points when looking at data aggregation, API gateways, and exposing those data points, Gartner brings up that there are very many overlooked areas. And we see these here on the right. You see scalability issues, latency, throughput, 24/7 availability, agility for change. These are the areas that when you simply look at this from a plumbing perspective, you might not be considering actually what's needed to service up real-time API requests in a low latency and high availability fashion. So there's a new emerging architecture that replaces this conventional one that addresses all these challenges, right? So Gartner identified this. They call it the Digital Integration Hub, or DIH. And the important difference that I want to note, we talked a little bit earlier about request-based data coming from system record. We talked about tightly coupling. Well, in the DIH architecture, it's actually event-based integration. So that's a very key point here. We are decoupling the digital application from the system of record. So if we look at the top of the diagram now, we see these multi-protocol APIs. We actually can expose data over unified data models, even though we have multiple disparate systems of record. And we can actually help accelerate the introduction of new microservices using this model. And this is all made possible by the data management layer in the middle. Okay, this includes a high-performance data store. So don't confuse this with just a simple cache, where you're simply caching data that's passing through or most frequently accessed data. We're talking about in-memory or a hybrid in-memory data grid that provides all the relevant data, offloading that from the backend systems of record. And then finally, on the systems of record side, pluggable connectors really have the job to actually pull the data off once from the system of record, right? So if a new event comes in, it's pushed into the middle data store as opposed to waiting for a request to come in. So in real time, data transactions, data can be loaded through streaming and so forth, that you always have updated data in your DIH. So what are the benefits of this? Of course, as we mentioned, from a business aspect, we can accelerate innovation. So we're looking to have go toward a digital journey, getting more and more digital experience for our customers. We can launch multiple digital apps faster and improve that customer experience. all the while reducing the costs on the back-end system of records. From a developer standpoint, we really look at this as a unified data model. It's a data-first approach. So when I'm developing an application, I don't have to worry about building access to every back-end resource that I need. It's already done for me. It creates an environment where I have faster and simpler application development. I can have less custom coding because these are ready-made system of record connectors to the back end. And then finally, from an operations standpoint, we can handle peak loads. We know what to expect. Somebody's not commandeering my existing applications, but I actually have a dedicated stack to handle the digitization of these new applications and microservices. Okay, so now we talked about some of these challenges, right? Let's take a shift. Let's look at an example of what Gartner sees as this DIH, and of course, it's the GigaSpaces Smart DIH. So what you see here is our architecture. It's a GigaSpaces stack. And at the bottom, again, we see systems of record of various types. I want to highlight here that it's not just, a bunch of relational databases. We can actually have completely different types of data repositories. So relational stores, you see MySQL, Oracle, Postgres, for example. We can actually have various data feeds coming in through streaming services like Kafka. Perhaps it's newer databases like NoSQL and document stores. All of these can be brought into the DIH through our integration layer, which is responsible. We have pluggable connectors for data sources, responsible for bringing the data in. If we're running various processes for CDC or ETL, those data can be pulled in, adjusted, and brought in, validated, and cleansed into the DIH. And then finally, the data is actually written into the in-memory data grid, the hosting layer of the DIH. Essentially, this is really key here. It's based upon our distributed in-memory data grid. It actually offers low latency, it's tiered storage management, and it balances the cost by placing high priority data in what we call hot storage. So think of memory as being ultra accelerating, right? It's going to accelerate the data access in your services, but it comes at a balance. If you have data that you want to be pulled in and unified into the DIH, but also not necessarily needing it to be extreme performance, you could actually have a hybrid model where you have storage in RAM and an SSD. So this in-memory data grid offers that tiered data access over a low latency platform. And then finally, it's distributed. You can have resiliency and the ability to actually have nodes go down and up and so forth without actually affecting access to the data. And then finally, the digital layer on top is responsible. It actually will expose the digital apps, the data that they need through Java, SQL, various APIs, .NET, or RESTful services, and host this data over that unified data model. Okay, so we're really talking about an overall solution orchestrated by the monitoring control capabilities offered on top of Openshift. So let's apply this to an example. We have an example here of a customer-facing application, very simple diagram here. But the main point I want to show here is that we have these applications that are accessing back-end systems, core systems, to offer a customer experience through, in this case, a web interface. The question is, how do you actually offer access to this information to other third parties? So for example, in different geographic locations, I might have a requirement, a mandate by government to offer open API access to financial information for citizens. Perhaps I want to do this instead, maybe in the States where I have third-party fintechs gaining access, and in many cases, and probably still going on, where they'll ask the customers for application access, my credentials onto my bank's platform. And this creates a couple of issues. One, it creates a potential security issue where my credentials are being shared out. Two, it's not my user experience. If I'm the bank and I'm actually exposing this application, I can't control that. It's unlikely that I'm going to offer an API that gives direct access to my core data. And of course, I'm not going to actually host somebody else's application on my network. Unlikely. So what would this look like in the Smart DIH platform is that we would actually take only the data that we want to expose to this API. And instead of offering it through our existing applications, our custom experience, we provide an API stack or a microservice. We integrate the data. We actually will host it based upon the need of the API, and actually provide various microservices in a simple way. Now, I'm talking right now about opening API banking. I'm talking about exposing data externally, but this is very well could be used for internal resources as well. So if I want to actually expose a BI tool, if I want to expose data to different dashboards, if I want to actually provide microservice for other internal applications, the Smart DIH can do both of these things all at once. So let's actually look at what this means like in a development cycle. So we've kind of talked at singularity level of a DIH stack, but how do we actually manage the journey considering the full CI/CD cycle? What we're going to talk about here is about 3 different environments. I know in some cases there are many more, maybe it's UAT and so forth, but we're going to talk about development, production, and then cloud in a hybrid production environment. And first, when we actually pull data in, we can have a stack of the Smart DIH with various development utilities. We're actually going to show a process where no longer do you need to have 25 people involved to actually deploy a simple microservice like a RESTful application. I can do this in a no-code fashion in a very, very efficient manner. The second thing I want to talk about is really the ability to actually have provisioning across an orchestrated Kubernetes layer, and we'll do this through Openshift. And then finally, we're going to pull that data and stream that data into that on-prem environment directly using those connectors we just used in our development environment. Finally, we can actually deploy our no-code microservices into the production environment. But really the creme de la creme, the big piece here in our journey to the cloud is how do we do this in a way that we can actually have a hybrid model and actually deploy in a safe way our data. We use what we call our WAN gateway to deploy data to our cloud instance of the Smart DIH. And this really offers us that benefit where we're exposing this useful information, this great information of customers. Maybe we have to, as I mentioned, maybe we want to, but I'm actually not exposing my core services to the internet. Okay, so let's shift over to actually see this in action. I'm going to actually end the slideshow here. You should see my screen backdrop now. And I'm, as I mentioned, a bit ambitious, but we're actually going to build up the Smart DIH and microservices from the ground up. First, you see, again, at the bottom, I have various systems of record. So if you look at my MySQL setup here, I have three databases. I have MySQL, I have Mongo, and Kafka. I want to take a peek real quick at what's in this MySQL database. And if you see here, hopefully you can see, I'll explain it if it's a little bit small. I might suggest in the webinar you maximize your screen to get a better look. But inside MySQL I've connected to, I have 3 tables. I have accounts, account client links, and client. I'm just going to do a quick query against the account tab because this is the table I'm interested in pulling into the DIH. I see I have 4,500 records. It's a very small demo data set. I can take a peek at what that data looks like very quickly and see that I have just a few fields. But my point is not so much about the specifics data in the demo, but I want you to follow the process. I want you to follow the process where I'm actually taking data from that underlying system of record and pulling it into the DIH. I also have data in Mongo, so some NoSQL data, and I also have Kafka streaming that will show. Well, let's start off with that MySQL data. So here you see my on-prem, my development environment for the GigaSpaces Ops Manager. And you'll see as I show my demo, I'm actually going to pull in different components into these boxes so that you can keep it straight. We have a web interface to the Smart DIH, and we also have console line access to my Smart DIH, both running on the development environment. So let's maximize my web-based interface here. And I'm actually going to connect to a data source. Which data source? Well, the data sources that I'm interested, I can apply the plugin connectors. When I click on this, I see which ones I have loaded for my environment. And I can actually say I want to load MySQL. I need a connection string. And luckily, I did this before, so it's already cached for me. But my connection string is connecting to this database at 3.136.16627. It's connecting to the DIHDB. This is my test database. And I'm going to put in the credentials for access to that. So pretty much just straightforward standard JDBC type connectivity URLs. But I have the ability to actually add some advanced features to how I'm going to deploy my data. And the first thing I see here is how many partitions do I want to deploy? And for this demo, I'm going to deploy 4 partitions. And I'm actually going to have 1 gigabyte of memory per partition. So my data will be distributed across these 4 partitions, as you'll see in a moment. Eventually, when I go to production, both on-prem and the cloud, I'm going to want some resiliency. I'm going to want high availability. For the dev environment, I'm not so concerned with that. And you see some other options I have to control how that data is stored in the grid. But my point right now here is really just to pull the data from MySQL. So I'll hit next, and I'll be presented with the tables that are in my SQL database. I'm going to select the table that I was interested in, which is just the account table. And I have other options. I can actually optimize the storage. I can compress different elements of the data. Something very important to understand is also the ability to index data. And so as I'm importing the data, I'm going to make my selections and eventually, using what we call one-click deployment, deploy my data. So I've selected the account table, and I'm going to deploy. Now, in this process, what's going to happen is we're going to connect to MySQL. I'm going to actually shift off this page and show you what's happening from the aspect of the GigaSpaces Smart DIH's services. So as that deployment goes, we're actually going to create a service. It's first creating something called a demo mirror service. And then in a moment, you'll see the actual in-memory data grid come up, which is those 4 partitions that I requested. And it will actually pull the data into those partitions. And this should happen relatively quickly. What will happen now is when this becomes healthy, we see my partitions in the space. We have the service. I'm going to take a deeper look into the service. Again, we're in our development environment. We don't have backups running because I'm not so much concerned about that. I want to actually get to the point where I'm developing microservices. Nothing much is going on, not much CPU usage. I can see that the RAM space has been taken up. But this is all about the service. Let's actually see what data we pulled in. So if I click on this space icon, the data in our in-memory data grid, we call it a space. So it's in the demo space, and I can see a survey of that data, okay? I can see that I currently have 1 object type within the data, and that you can think of that analogous to the table that I pulled in. So within that object type of account, I can see the fields, the subfields inside the DIH. There are various utilities we can use to actually, do a SQL statement against the data and so forth. But the point here is right now that I have actually pulled data into the GigaSpaces development DIH. Okay. The second aspect we want to do here is actually we want to create more connectors for the other data types. So I have Mongo, I have Kafka. For Mongo, let me just pull over the view into the Mongo database store. I have a Mongo database called test. Now inside a NoSQL database, we don't have tables anymore. We have what we call collections. So I have a collection called customer. It has 109 customer documents. And you see here that this is a completely different type of data store. We're storing NoSQL. We're storing more like JSON name value type pairs, but it's no big deal. We have a connector for that. So let's go ahead and invoke the connector and import my, my customer collection into the DIH. What we're going to see here, and a lot of this is scripted, so I'm going to go ahead and pull the data over through scripting. I don't know if we have enough time to do every single thing one by one. So we've actually stacked this up a bit in a script. So I can actually run the services this way. And what you'll see is a bunch of different pluggable artifacts that are actually being deployed into the Smart DIH. The first one deployed already. We have something called a service creator. We're actually deploying the Kafka adapter. And so while this happens, I'm going to reopen my Smart DIH to see what's happening as far as my services go. And you see here, the first service that was created is this thing called a no-code service creator. This has that ability so that other folks, not database administrators, not the folks on the back end, but actually my application developers, I'm going to expose a service where they can actually create their own microservices. In this case, a RESTful microservice. As the other services come up, you're actually going to see other service components up here, and they should all come up in a nice, happy, healthy state. But so far, what I've done is I pulled the data from MySQL. I'm in the process of deploying the connectors for Kafka, and I will pull the data in from Mongo. So while it's deploying, let's take one more look over at what's happening from streaming. So for streaming events, for Kafka streams, for data coming in that fashion, you have the concept of the source application, which is publishing transactions. And the Smart DIH connector is able to actually become a consumer to that queue. to consume those event messages or those transactions in this case. We're going to emulate that by feeding transactions from a CSV file into that queue. So taking a peek here, I actually have some examples of those transactions that we're going to feed. Classic CSV type stuff. The one thing I want to show here is that we actually have amounts as one of the fields, 1,000, 300, 800, and then eventually we get to an amount ABC. So that's actually not an amount. So what happens there? Well, the smart DIH is able to actually do validation and cleansing and actually can handle those types of inaccuracies in our incoming data. So my script finished, and let's see what I have. So I'm going to go back to the smart DIH. I'm going to take a peek now in my services. Now you see I have a number of plugins that actually were loaded up. The cleansing plugin that I just talked about, the plugin for Kafka to consume the Kafka queue. I have a CDC adapter and I have a Mongo adapter. And what's cool is if I now go look at my data, I have a really great view into a unified data across 3 different data types. I have accounts coming from MySQL. I have customers coming from Mongo, and I have this thing called transactions. But wait, I don't have any transactions yet. Well, in fact, I've actually loaded the connector, but I have not yet started feeding transactions. Okay, so let's go actually start feeding some transactions through the Kafka stream. And again, I can do this through a very simple script, but it's actually going to grab those transactions one by one and put them into the smart DIH. Okay, so let's go back again. We have the stream coming in. Let's go take a peek at what's happening. We start to see that our transaction volume is increasing. We have a periodic refresh here that will show that my transactions go from nothing to actually now streaming in live in event-based information. Okay. So what good is all of this unless we can actually use the data? So again, I like to repeat myself a bit. We've ingested the 3 different data types. We brought it into the smart DIH. It's sitting in that hosting layer, the in-memory data grid. Now I actually want to show you a no-code way using that plugin connector, the no-code service creation, to actually expose this data. So this is really kind of the cool part of things. I'm actually going to open up a demonstration utility here, which is a no-code services example. And I want to create a Restful microservice. I want to create a Restful microservice that is simple to do. I want to create the ability to expose some transactions and accounts. And so I'm going to go ahead and use this utility. Again, no code. I'm going to call my service getTXN for get transaction. I want to actually expose this on port 8116. And then what do I actually want to return? I want to make a RESTful request and I want to return something. So I'm actually going to paste a SQL query here. And in my SQL query, you see that I have a number of things. It's really just selecting everything from account where the account and transactions, where the account ID matches the transactions account ID. So we basically have an implicit join. And where the account ID equals the first parameter and the account type equals the second parameter. So I need to actually specify that this RESTful service is going to need some parameters. So I'll go ahead and put those ordered input names. And with just that, pasting a SQL query, adding the parameters, the port that I want to put it on, and the actual RESTful endpoint name, I've gone ahead and deployed my first no-code microservice, right? So you can write a description for your microservice and go ahead and deploy it. So I've done that, and go ahead and create that microservice. Now here's a very key point. So far, we've only really talked about pulling in data and plugins into the GigaSpaces Smart DIH. But the point I want to make here is actually this endpoint API, this RESTful service, is now going to reside co-located right in the same Smart DIH as the rest of my data and plugins. So it actually becomes very efficient. And as you see the deployment come up, you'll actually see my get transaction service be deployed as a pod and actually will be, here we go, right here, be available in the same memory space. Okay, so what do we have here? We have a RESTful endpoint based upon that unified data model. Again, we're still in development here. I've gone ahead and done this. So why don't we actually go and see what we get from this get transaction? So I'm going to actually go over to a test utility. I'm going to use Postman, which is actually going to give me the ability to see what comes back in that RESTful service. So here I am. Here's my client looking at development. And I will enter the endpoint URL. Actually, I have this ready on the side. It's actually going to hit that same URL, and I'm going to give it an account ID of account number 192, and my type is this Poplatech account type. And so when I rip off this RESTful request, I get a response back. And it's not all that pretty, so let me just change Postman to view in JSON format so the picture will become clearer. I actually just did a no-code microservice build and deployment that actually aggregates data from multiple backend systems of record and exposed it through a RESTful interface. So really, really simple, really quick. You have the capability of doing this, but that was all in development. So let's actually go through a process of bringing this to the cloud. So in my cloud deployment, I have a couple of things to consider. I do have the ability to actually deploy on-prem, as we mentioned, so Openshift running on-prem. The key difference here is you see that in my service environment, I actually wasn't running on a cluster. So if I take a peek, you'll see welcome to the GigaSpaces Ops Manager running on Service Grid. So you don't necessarily have to always run this in development on a full cluster. You can actually run this on a laptop and develop APIs depending upon what you're doing. You can actually run this on a dedicated segmented network where you extract data. You can still leverage the same generated resources, same generated artifacts and applications and push them out to production. Similarly, when we actually import data, I'm going to need to have my data connectivity. So if I look at the services, I actually have demo data, and I have the plugins for Mongo, Kafka, and the MySQL database. I don't necessarily need all those service creation tools because, again, we're in production. All that happened in development, and so I can just simply take that artifact and deploy it. In this case, I will show Jenkins deployment of that artifact. Okay, so we're looking to go to the cloud, and so what we're really interested here is how can we actually deploy to OpenShift in the cloud. So if I'm looking at my OpenShift instance on the cloud, I can take a look and see what we have. Now you recall a moment ago when we were looking in development, we didn't really care about high availability. In this case here, I actually have 4 partitions running as pods, and each one does have a highly available partition. So I have a primary partition, 1-1, and I have a, 1-0, and a secondary partition, 1-1. Okay, so if one goes down, the other one will be readily available. I also have the data split across 4 partitions. And then finally, I have an interface between the Smart DIH and OpenShift orchestration. So what I can do here is actually take a peek at my on-prem instance, my cloud instance of the Smart DIH, and I'll pull over a window just to do that. Let's minimize my OpenShift here. Okay, so I need a URL. I need to find out. So let's actually reopen OpenShift and take a peek at where that's being hosted. I can see that I have this manager service on port 8090. So let's take a peek at the FQDN for that manager service. And quite simply, I can go back to my interface. I can plug in my endpoint. I know I'm hosting that ops manager at port 8090. And I take a peek at the instance of GigaSpaces Smart DIH running on OpenShift in the cloud. So what do I have in the cloud here? So we saw with the development instance, we had all the bells and whistles, the development tools, all the plugins, access to the data and the systems of record. For the on-premise instance for production, we had, again, access to the data, but I didn't necessarily need all the tools. But now we're actually in the cloud. And so really what I want to do is make sure I protect which information I copy to the cloud. I don't want access right back to my core systems. So if I actually look at my cloud implementation, look at those services, all I see is the data. The data has been replicated using our WAN gateway interface. I don't need the development tools. I don't want access to my core systems. Okay, but I still do want that API access. I still want that ability to push out that resource. So let's go ahead and do that. And again, just simply using your traditional tools. In this case here, Jenkins, I'm going to use. I have a job in Jenkins. Let me just log into Jenkins. And we have a job basically that was created, push and deploy on Openshift Cloud. Okay, I won't save that password. And if I click on this job, I can actually run the job build with parameters. It's all set up and ready to go. I can run this get transaction. I just need my server endpoint. And again, I'm pushing to Openshift. So let me actually open up Openshift and grab that. I want to make sure that I'm in the right spot. So if I look at the manager, what is the URL to push this to? It's here. I'll grab that URL. And that's the endpoint FQDN that I'm going to give to my Jenkins job. Now, again, we've already developed this resource using no code. I'm simply telling where to push it. When I actually build this no code RESTful service, I'm going to push out to Openshift. And Openshift is going to create a job for me, create a pod for me to deploy the actual microservice, the RESTful application. So let's see what's happening over here. So you see now I have a new pod, get transaction. I can see what's going on here and what's happening. It's exposing. We should see this as familiar. We told it to expose port 8116 on the endpoint, so that's fantastic. We got 8116. I can take a look at the actual URL. In this case, it's a cloud-based URL. And I can go ahead and test it. So let's go back. I should see something very similar to my earlier test. And what I see here, let's open up a new tab. There's my endpoint. I told it to be on 8116. And I need the rest of my URL, which is the endpoint name was get.txn. And I need to have an account ID and an account type. Okay, so we see my parameters 192 and pop the tech machine as my account type. I'll run that. And once again, we're in the cloud. We had our no code microservice deployed. And I see data across a unified data model, all enabled through deployment of the Smart DIH in a hybrid model, all dependent upon on the underlying topology, the orchestration provided by Openshift. So, as I mentioned, a very ambitious and involved demonstration here. But to summarize things, I want to make sure it's clear that we took what was once a resource problem and actually turned it into a benefit. We can actually expose a unified model and actually accelerate API deployment, accelerate microservices and applications, facilitating that digital journey for the end customers, and do it in a way that is actually economical, secure, and efficient, not requiring expertise at every level from your back-end data folks. So with that, I want to actually circle back and hand over the presentation to Sim. If I can stop sharing, one moment.
There we go. And I hope you can see my screen now. Andrew, that was pretty amazing. I always enjoy seeing practical applications developed using cloud native methodology that fully use the power of hybrid cloud. It really shows off what our platform can do. I'm Sim Zacks, like the card in your cell phone, Sim. I'm a distinguished engineer from Red Hat. I work as a DevOps and CI architect for the past 6-7 years. And I'm going to take you through a number of the advantages of the platform that we just saw all of the different advantages for. I just thought, yeah, sorry. Oh, sorry, I thought I heard somebody talking. Of Openshift for the hybrid cloud. So when you're looking for a cloud native platform on which to integrate your enterprise level application, Openshift is a very clear choice. At its core, Openshift is 100% Kubernetes. And Kubernetes is the industry standard for container orchestration and management, but it's much more than that. While Kubernetes is known as infrastructure as a service, Openshift is a complete platform as a service, and we'll discuss what that means in just a moment. So aside from that, Openshift is flexible, enabling the administrators to choose various ecosystems without lock-in. Every part of Openshift, even those parts that aren't in vanilla Kubernetes, are fully open source. You have the ability to look behind the scenes, understand exactly how every component is working, as well as contribute code if you want to add in any new features. It's a great platform for the open hybrid cloud, as it'll provide a consistent operator and developer experience, no matter where it's deployed, on-prem, or on any public cloud. Openshift leads the hybrid cloud market for application platforms. As you can see on this chart, our customer base is steadily growing. Red Hat very actively participates in the open source communities that our products are derived from. This enables us to influence the direction of the projects for our customers' interests and to stay at the forefront of technology so that you will always have access to enterprise quality of the latest and greatest on the market. Now, I mentioned that Kubernetes is known as infrastructure as a service. There are tons of components that can be integrated into Kubernetes. Each Kubernetes deployment is going to be unique, including the interface, the methodologies needed to interact with its components, and the total workflow. So after spending the time and energy determining what you need and testing it to make sure it works the way you expect, you will have your platform. However, each public cloud that is offering Kubernetes as a service develops this platform on their own. They generally make it dependent on their own infrastructure and services as well. Openshift, on the other hand, is platform as a service. Every deployment of Openshift provides a consistent experience for both operators and developers. All of the components needed for a cloud-native experience are provided as part of the Openshift deployment. Openshift starts at the bottom, as you can see here, with Red Hat Core OS, giving the entire platform an enterprise-level operating system. You then have the core Kubernetes engine, giving you the full power of container orchestration. The Kubernetes cluster services are all included as well, including operators, monitoring, logging, storage, and networking, to mention a few. The services that come with Openshift are installed on top of that, which include platform services such as service mesh, serverless functionality, CI/CD pipelines. There are application services such as specific language and runtime templates, API management and integrated messaging, data services, which include various kinds of relational and NoSQL databases, data analytics and insights, as well as an AI/ML engine. There are also developer services such as S2I, source-to-image functionality, giving developers a native, agile, continuous deployment framework and a cloud-native IDE for collaborative development. At the top of the stack, you have advanced cluster management, enabling to manage all of your Openshift clusters, whether on-prem or on public cloud, from a single interface. In summary, by integrating applications with Openshift, you get all the features of Kubernetes, plus the standardization and added functionality that Red Hat includes. You can add on top of that multi-cluster management, enabling you to control all your Openshift deployments from a single source. So with that, we can fully understand why GigaSpaces chose Red Hat and Openshift for their platform, because in order to do such amazing things with in-memory storage, you've got to have a strong platform. Thank you very much for participating.
Thank you, Sim, and thank you, Andrew. This was awesome. And let's take a look. We got a few questions during the presentations, which we already answered. However, we still have a few questions left. So let's see in the next few minutes, in the time that we have left, we can take a few of those questions. By the way, the questions that we will not have time to answer right now, we'll of course make sure to follow up with you guys and provide an answer for each one. So Andrew, I think this is for you. You mentioned pluggable connectors several times. What exactly do you mean by pluggable?
Andrew, it looks like it sounds like you're muted maybe.
Thank you.
There we go, no problem.
It was such a wonderful answer too. I was mentioning that it was a great catch in a very important aspect, because when we talk about event-driven data coming in, when we talk about a pluggable connector, it's that ability to make that connection out of the box. It's not bloatware, so we're not going to install by default everything under the sun, right? But you have the ability to plug these components in, which you can then act as an interface and plug to the data system of record. So for example, Kafka consumers, if we're talking about reading off a Kafka queue, or leveraging the connection to a relational database like Microsoft SQL, you can load that connector, you can actually make the connection to the data resource and pull the data in. So pluggable from the standpoint of configuration installation, but also pluggable as from the aspect of into your environment and gaining access to that data.
Awesome. Thank you, Andrew. And another question, which clouds can you be deployed on?
I think I'll take the first half of that. Maybe I'll drop it over to Sim as well. So from our standpoint, the GigaSpaces deployment can reside on Openshift, whether it's on-prem or cloud. We can actually deploy, as you saw in a development environment, offline. And I think I saw earlier a question about, can we deploy into an existing Openshift cluster? And the answer is absolutely yes. As it relates to the benefits of, where Openshift is, maybe I'll hand that over to Sim.
All right, so Openshift can be deployed, both on-prem and in various public clouds. We currently are fully supported on AWS, Azure, Google Cloud, Alibaba. Those are the ones that I know for sure that we're testing on and making sure that they're fully compatible. But any other cloud that wants to deploy Openshift, it can be deployed on it. But those are the ones that I know are fully supported right out of the box.
Thank you, Sim. And folks, if you have additional questions, now is the time. You can type them in the Q&A box. And let me see if we still have some unanswered questions. Let's see it real quick. Do you need a dedicated OpenShift cluster? Can your application be deployed on an existing one?
Yeah, and that's actually another great question. So I think it's important to note that the demonstration, of course, is just that. It's a demo. So we have a dedicated environment where we spun up in order to push the data. Now, of course, in the cloud instance, we didn't invent our own cloud, right? So we actually leveraged an existing provider and threw onto that orchestration, onto that OpenShift. But our on-prem environment, yeah, we did. but that's not a requirement. Of course, the whole benefit here is actually not having to go from ground up with everything. You want to leverage the power of having a cluster. And so, yes, we can put it into an existing cluster, simply allocate the necessary resources to deploy those services in pods. And then was the second part of that question was, sorry, no?
Run it again.
I think it was the existing.
Can your application be deployed on an existing cluster?
Yeah, and the answer is absolutely yes. So whether one aspect, maybe you have Openshift running on-prem and you actually want to leverage Smart DIH and push also to a hybrid model of the cloud, no problem. No problem there. Or vice versa. Or if all your data is already in the cloud and you want to have Smart DIH going from cloud to cloud on Openshift, no problem there.
Right. If I can step in as well, one of the advantages of Openshift over Kubernetes is the role-based access. So you have various projects. So every project is isolated from the other ones within Openshift. And so you have full permissions and security involved in that. And so you can have multiple different types of applications on the same cluster.
Awesome, great. Thank you, guys. So again, we'll make sure if there were still questions that were that went unanswered, we'll make sure to follow up with you guys. And at this point, I would like to hand it over back to Charlene for some closing remarks.
Yeah, great. Thank you very much. What great questions that came in. As Noam said, if you do have a question, please, it's not too late. You can go ahead and get it in, and we might be able to address it before the end of the webinar. Otherwise, if we're not able to, I'm sure the folks will be able to answer your question offline. Excuse me. Real quick, want to remind the audience that today's event is being recorded. So if you missed any or all of the event, you will have the opportunity to access it later. We are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars and look in the on demand section, and it should be right there waiting for you. Okay. I'm checking. Doesn't look like we have any other questions coming in. So why don't we go ahead and do the drawing for the $425 Amazon gift cards. Let's see. Our first winner today is Thomas L. Congratulations, Thomas. Our second winner is Daniel P. Congratulations, Daniel. Third winner today is Sandy R. Congratulations, Sandy. And our fourth winner today is Tiffany D. Congratulations, Tiffany. We'll be following up with all four of you offline by email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam folder. Well, guys, I guess what I love those demos. I got to tell you, Andrew, I just love watching the demos. So thank you so much for doing that. But Andrew and Sim, both of you, please, I do want to thank you both for a great presentation and such great takeaways. And like I said, I love those demos. So thank you again. I appreciate it. Great to see you both.
Yeah, definitely a pleasure, Charlene. And Sim, thank you so much.
I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and
always a pleasure.
You bet. All right. Have a great day, everybody. Enjoy your day. Stay safe. Thanks.